Okay, so on your Schoology page, you see that we've got our semester 1 is still there. Okay, so I kind of showed you guys that yesterday. Just wanted to make sure you guys knew it was still there. And then if we open up our folder for today and this week, and today again, there you go. All right, so we are doing Law of Conservation of Mass today. So I kind of put in there some of the notes from yesterday. So that was still on the Jamboard. If you go back to yesterday's little folder, it's there. But I gave you guys a new Jamboard right here. So you do want to click on that if you want to follow along on the Zoom call again, which I do see that there's a few of you guys. Nope, not on this one. So when you do open it up, I would go to slide 7, okay? So I will go ahead and put it into the chat in case you want to do it from there to take your notes. And again, you can just kind of keep the sound kind of in the background and watch what we're doing on the screen by being on the Jamboard, okay? And then you do have an exit ticket to make sure you complete today. I'm going to go through and I'm going to start begging people who've maybe skipped both days. I don't think there's anybody on this list though. So, so we're going to go ahead and do that. All right, so slide 7 is what we're on. So if you are in the Jamboard, make sure you go all the way to slide 7. And again, the place that you're getting that from is right at the top of our little list up here. And if you're just following along on the Zoom call, that's fine. Just make sure you can see your screen. All right, so on slide 8, so just go ahead and go to slide 8. We're going to look at our most missed question from yesterday. I do want to take a second to review this because it didn't go so well yesterday. Like we literally had like 60, 70%, not 70, I think 60% on this question. So it's really important that we know how to do this in order to be successful tomorrow with the balancing, right? So when we had this little formula given up here, and you have a 3 coefficient, it meant that the way some of you guys are thinking about it is you're like, okay, well, subscripts go with what's in front of them, and then if I have these parentheses and that 2 goes to everything inside the parentheses, and then this 3 goes to everybody behind it, right? So that's kind of what we've learned, but I don't recommend that you guys do that if you're not being very successful with that. So that was question number 5 yesterday. Okay, and so a way that you can also do this, and tomorrow it's going to be known as kind of the box method, is a little bit more visual. And I do recommend that, okay? And so what you're going to do is take a look at, so we know that we have magnesium, and then this PO4, which is phosphate, is going to look something like this, okay? And so when you go to draw out this whole molecule, right? You're going to end up having Mg written 3 times, right? So Mg3, PO4, so POOOO, but there's 2 of those for every single one of these molecules. So we're going to draw one more, okay? And this right here is everything that will go into a box tomorrow when we're doing that visual way, right? So that's one molecule. So once you know that that's what one molecule looks like, then we're going to actually use that 3 coefficient to say that we have 3 of these. So we have 3 of these boxes, which means that we would draw it one more time. Okay. And that would give us 2. Right? So there's my next molecule, but we're going to draw it one more time because it wants 3. And then you'll be able to see the number of everything that you have. Tomorrow, it's going to be super important that you're able to count, because if you can't count, then you've lost that battle, right? Because the counting part is pretty much like 3/4 of that battle, is you got to know how many you had to start with in order to balance it, because now you're going to deal with 2 sides of the yield sign, right, of the little arrow. So looking at this, you can now see that we have 3, 6, 9 magnesium. So the answer there should have been 9. Phosphorus, you had 1, 2, 3, 4, 5, 6. So we had 6 atoms of phosphorus. And then oxygen, we had 4, 8, 12, 16, 20, 24. So once you had those, then you could add them together to get that total number right here. Okay. So that's just a little recap of that question, because like I said, it was the most missed question on the quiz yesterday for all of the classes. So just want to make sure that we touch base on that. All right. Now I'm going to go to slide 9. I am seeing that most of you guys are not on this. So can you guys see it on your Zoom screen? Yeah. You're able to see it from up there? Oh, okay. All right. You guys at home, you doing okay? I don't know. I just know it's very tiny. That's why I'm sharing that on a Jamboard so that you guys can actually see a big screen of it. Okay, I'll keep going. All right, so this one, words to equation. So we have 2 units of aqueous potassium iodide. So we're doing this just to continue practicing writing things out and writing the formulas. So if we have 2 units of something, that means that we have 2. Okay, we have aqueous potassium iodide. So we know that aqueous is going to look like that. Potassium iodide, we would find on our periodic table, which I did add to the slide. So we have a potassium right here. Iodine is over here. So that means that we have a +1 and a -1, right? So we have +1 for potassium, iodine with a -1. Those guys crisscross, and we end up with Ki as our formula. So we have 2 Ki's. We're going to add that little aqueous there, plus 1 molecule of chlorine gas. So I'm going to circle chlorine gas because if you remember yesterday, one of our topics that I went over with you was our diatomic 7. So remember, our diatomic 7 are all of these that I just highlighted, right? There's 7 of them, okay? And so as you can see, unless I covered it, but as you can see that we have chlorine, which is up here. We have chlorine up there. So what that means is that it's part of the diatomic 7. So when it's by itself, or if you see chlorine gas or iodine gas or nitrogen gas or oxygen, all of those, you have to put a little 2 next to it. So we have 1 molecule of it. So we're not going to have any kind of coefficient in the front. If you would like to start putting ones, you're more than welcome to, but you really aren't supposed to. So we have chlorine with a little 2 because it's diatomic. And then we're going to put the little G for gas. Okay. And then we have the word yields. So that's your arrow. 2 units of aqueous potassium chloride. So chloride is up here. So once again, it's going to be that +1, -1. So we're going to say 2 units of potassium chloride and 1 molecule of now iodine gas. So iodine is down here as part of the diatomic 7. So we're going to have I2 with a G. And I forgot the aqueous on my potassium chloride. There you go. All right. So there's that little review. Once again, bringing words to the formulas. You got to be able to do them interchangeably, okay? All right. Equation to words. So we're going to do this real fast, and then I want to spend time on what's actually being covered more today. But, oops, hold on. There we go. All right. So here what we see, we have 2 units of solid magnesium. Okay. And once again, we're just looking at coefficients. We're looking at what the state of matter is, and then we're writing in what the actual formulas are representing, right? So 2 units of solid magnesium react with 1 unit of oxygen gas, okay? So as you can see, I said oxygen gas. So that's one of those diatomic 7. So I was able to say that. If you wanted to, you could also say something like dioxide, right? So oxygen gas produces, so there's the arrow, produces 2 units of solid, and this is an ionic compound, so we're just going to name it as is. So solid magnesium oxide, right? Okay, so now that we have that, and this is a really cool reaction. I'm hoping that I'll be able to show you guys this week. Hoping, cross your fingers that they don't shut off everything again. So, but this is really cool because what it is there's a little strip of metal, and then we just put a little spark with it. We put it into some fire to kind of get it going, and then it reacts with the oxygen that's actually in the room, and it creates ashes at the very end, which is this magnesium oxide part. Okay. All right. So about today. Okay. So let me kind of put this front and center right here. Okay, so it says mass is neither created nor destroyed. Easy enough, right? So mass is neither created or destroyed. Energy is neither created or destroyed. Okay, it's conserved, and it might be converted into a different form or rearranged in terms of mass and chemistry, how you guys have kind of seen these things happen. So if I begin a reaction with 100 grams of reactants, I have to end with 100 grams of products. Okay, so what that means for you guys on your assignment today, unless you've already done it, and I'm sorry, it'll be more of a review, but your assignment today kind of sets you up with things that look like this, okay? So it gives you a word equation. It doesn't necessarily write this out, but this is the part that you have to do. Where if I have 3 grams of solid magnesium and I create 5 grams of magnesium oxide, how much of that oxygen was used? So just like I told you in the story that this oxygen is floating around my room right now, it's a whole room of oxygen. That's why we can breathe, okay? If it only uses a little portion, you can actually solve for what that little portion was, okay? Using your conservation of mass. So what you're going to do when you do these problems on your homework today is you have 3 grams excess and 5 grams. So how much of this got used, right? The yield sign is an equal sign, okay? So when you go to look at this, you're going to have 3 plus something equals 5. And I bet you guys can do that one in your head really fast. It is that simple. Do not overthink this, okay? We're not even considering atomic masses or anything like that. You'll have plenty of time to do stoichiometry later. So it is literally this easy. We're going to do 5 minus 3 to get 2 grams. Okay. All right. Next example. We have now 24 grams. Okay. We have excess oxygen again. That happens a lot. There's a lot of oxygen on the planet. Okay. 26 grams of carbon dioxide is formed and 16 grams of water is formed. So once again, I have it already situated for you. Okay, I'll show you on the next slide what it's actually going to look like on your work. But you have 24 plus something is equal to 26 plus 16. So you're going to solve for this part first. So you get 24 plus something is equal to 42. And now that you have it in this terms, you're able to subtract the 24 and you should be getting 18 grams as your final answer. Okay. On the next slide, I'm just showing you what it actually looks like on your work. So the good news is that it's not going to completely look this way. This is how the problem is going to be set up. However, if you notice, there is no formula given to you. It has to be given to you, or you guys are going to have to write it by the end of next week. All right. So we're going to still do number 6. So it says from laboratory process designed to separate water into hydrogen and oxygen gas, known as electrolysis, right? So we have water, which is H2O. We need to, and it's liquid. We're going to separate it into hydrogen and oxygen gas. Both of those guys are diatomic, so we're going to say H2 with a little g plus O2 with another little g. Okay, and then to balance that, I told you guys you're going to worry about that tomorrow, but I'll still do it for you right here. There you go, okay? So this right here is the missing piece that you needed. Okay, and on one of your problems, you need to be able to write this out. It's the rocket problem. And just so you know, this is it right here. It's just reversed. So if you want to write that down, I would. If you guys have noticed, we kind of use this example a lot. All right. So when you're given that, now you can actually use these words a little bit more in the numbers, right? So we have 10 grams of hydrogen and 79.4 grams of oxygen. So it broke down into those two amounts. How much water was there to begin with? We have to conserve mass, right? So we end up with this problem right here, which is really simple. I'm hoping you guys are getting the point that do not overthink today. It is literally adding your things together, right? So you would end up with 89.4 grams as that final answer. Make both sides equal each other, and that's it. So I think you guys can handle today. Are there any questions that you guys have for me from home or from here? No? Good? Okay. So if you do have questions, stay on. Otherwise, I will see you guys tomorrow. Make sure you're still showing up. Get your friends to show up. They all need to come to class. They need it. Okay. All right. Bye.